Good day, Engineer Taguba. We are the Group 1 from ME3104, and today we're going to present our laboratory experiment in ME415, or the ME Laboratory 1, which is about the viscosity of liquids. So first, let's proceed to the theory of this laboratory experiment. So lubricant is a substance which is used to control, more often to reduce friction and wear of the surfaces in the contact of the bodies in relative motion. The property of a fluid that provides resistance due to the movement of one layer of fluid over another, adjacent layer of fluid is known as viscosity. Viscosity is governed by the strength of intermolecular forces and especially by the shapes of the molecules of a liquid. It is a property that describes a liquid's thickness or thinness. So let's now proceed to the objective of this laboratory experiment. So our main objective is to identify which between the glycerin and castor oil is more viscous.
For the materials used for our uh, laboratory, materials, the first picture shows a long cylindrical glass jar, and then the second picture at the top part shows a transparent viscous fluid. Third is a meter scale. Fourth is a spherical ball. Fifth is a screw gauge, and sixth is a vernier caliper. Seventh is a stop clock, and eighth a thread. For the procedures of our laboratory, first is that we select the environment to perform the experiment from the select the environment drop down list. Second, the liquid for which the coefficient of viscosity is to be measured from the select viscous liquid drop-down list. Use the select jar diameter slider to change the diameter of the glass jar. Then, fourth is to use the select ball diameter slider to change the diameter of the glass ball. And then we need to change the distance between A and B by dragging the corresponding arrows. Fifth is that we need to drag the glass ball towards the jar and drop it into the liquid in the jar. Sixth is that we need to stop the watch. The stopwatch runs automatically as the ball reaches the point A and stops as it leaves the point B. Next is that the time shown in the stopwatch is noted. Click on the reset button to redo the experiment.
This section includes the experiments obtained values represented by tables. Above table shows the distance and fall time of the ball in glycerine during each trial in a specific time. For trial in experiment number 1, the ball dropped at a distance of 60 cm within 43.753 seconds, whereas for trial number 2, the corresponding distance and time consumed are 55 cm and 40.107 seconds respectively. At a time of 36.461 seconds, the ball dropped at a distance of 50 centimeters for trial 3. Aside from that, trial 4 acquired values of 45 centimeters and 32.814 seconds for distance and fall time respectively. And lastly, for trial 5, the trial 5 obtained 29.168 seconds as the time fall for 40 centimeter distance. Next is for the castor oil. Above table shows the distance and fall time of the ball in castor oil during each trial in a specific time. For trial or experiment number 1, the ball dropped at a distance of 60 centimeters within 24.475 seconds, whereas for trial 2, the corresponding distance and time consumed are 55 centimeters and 22.435 seconds, respectively. At a time of 20.96 seconds, the ball dropped at a distance of 50 centimeters for trial 3. Aside from that, trial 4 acquired values of 41 centimeters and 18.356 seconds for distance and fall time respectively. Lastly, for trial 5 obtained 16.317 seconds as the time fall for 40 centimeter distance. For the calculation, for glycerin, let density 2 to be the ball density, which is equivalent to 2,600 kg per meter cube. Fluid density for density 1, which is equivalent to 1,260 kg per meter cube. The acceleration due to gravity g will be 9.81 meter per second squared. The ball radius will be 5 centimeter for the diameter, so the radius will be 0.025 when converted into meter. For solving for the average velocity of the 5 trials from the water as fluid, the V average will be equal to the summation of the distance over time divided by 5. So for the first average, we have 0.013713453 meter per second. Calculating for the viscosity of the fuel, the equation density 2 minus density 1 multiplied by 2 times gravity times radius squared over 9b, we have 1.33135688 Pascal second. For the castor oil, likewise in glycerin, the density 2 will be the ball density 1 will be the fluid density, G for gravity, and R for radius. The velocity average will be 0.024514.829 meter per second. For the viscosity of the fuel, we have the same equation. We have yielded 0.74475319 Pascal second.
So for the self-evaluation, the first one is what is the unit used for determining the viscosity of a fluid? So the unit applied during the simulation is Pascal per second. Next is what is the formula needed to compute for viscosity liquid? The formula for viscosity liquid is density 2 minus density 1 times 2 gravity radius squared all over 9 times b, wherein density 2 is the ball density, density 1 is the fluid density, g is the acceleration due to gravity, r is the ball radius, and b is the ball velocity. The third one is what did you notice to the data accumulated of castor oil and glycerin? So it is clear that the higher the distance, the ball drop at a higher time. However, the shorter the distance resulted to a shorter time as well. It is well presented in the summary of the table for glycerin and castor oil. Next is do density of the ball as well as the density of the fluid varies in determining the viscosity of liquid. So based on the result of viscosity liquid, density of the ball and density of the fluid affect the resulted value of glycerin and castor oil. And the last one is between the glycerin and castor oil, which fluid generate more viscosity. So glycerin obtain viscosity of a fuel which is 1.33135.688 Pascal second, while the castor oil obtained 0.74475319 Pascal per second. So it is noticeable that the glycerin is more viscous than the castor oil.
The last one is the safety reminder. Since this experiment is done virtually, there are no potential harm while conducting it. However, safety practices should also be discussed for the preparation of performing the actual activity. First and foremost, it is important to take note of using the correct materials to avoid hazards and miscalculation of the results. Next is the student to perform the experiment should be well oriented regarding hazards, potential harm, and how they must follow the correct procedures of the entire experiment. It is advised to dress accordingly and wear personal protective equipment in order to make sure no one will be harmed. And lastly, take the experiment seriously. No unnecessary behavior because it might hassle others who are also conducting the experiment and affect the result of the laboratory experiment. That's all. Thank you.